This video is covering Chapter 4, which is going to talk about groupwise models. We're once again looking at Galton's height data in this video. This is the same data we've been using in class when we talked about variation in Chapter 3. Remember, in Chapter 3 we talked about explanatory and response variables. The response variable is the variable in which we are trying to understand the variation. For the Galton data set, that was height. And the explanatory variable is a variable that we suspect may account for some of the variation in the response variable. And some of the ones that Galton collected were which family the child was part of, the father's height, the mother's height, the sex, and the number of kids in the family. In Chapter 3, we measured variation in a variable without considering any explanatory variables. We considered an individual case to be equal to some model value plus a residual. And this was called the single value model. In particular, we measured variation in height without considering any explanatory variables. So we said that height was equal to the mean height in the data set plus a residual. And this single value model, since we're using a mean as our model value, is also sometimes called a grand mean model. And by grand mean, we just mean the mean if you group all of the observations in the data set together into one large group. We're not making any value judgments on how wonderful it is or anything. In Chapter 4, we are going to be looking instead at a groupwise type of model. With groupwise models, we use an explanatory variable to form groups. Then we measure the variation in response variable using different model values for each group. So for instance, an individual case in Group 1 will be equal to the model value that we choose for Group 1 plus a residual. An individual case in Group 2 will be equal to the model value for Group 2 plus a residual. And we can have as many groups as we like. In our situation, we're going to be using sex as the explanatory variable. So we're going to be considering height with a groupwise model that's going to create different model values for males and females. So here what I did is I summarized the height variable in the Galton dataset using sex to break the children's heights into two groups. So we can see in our box and whisker plot on the right that the median height is higher among males, and that the distribution, although there's some overlap in the distributions, that males tend to have taller heights than females, and we probably know that from experience. Also summarized the mean height for each sex. The mean height among females was 64.11, and the mean height among males was 69.23. The groupwise means model is going to model female height as being equal to the mean height among females, 64.11 inches, plus a residual. And for each male in the data set, it's going to model that male's height as being equal to the mean height among males, 69.23, plus a residual. If we were to go ahead and calculate residuals, since we have our model for females having height equal to 64.11 plus the residual, then the residual is equal to each female's height minus 64.11, and we could calculate that for each female in the data set. The male model for height is that height is equal to 69.23 plus the residual, which means the residual for a male in the data set is their height minus 69.23. So for example, Residual for a female who is 67 inches tall is 67 inches minus 64.11, which gives us a residual of 2.89 inches, indicating that a woman who is 67 inches tall is 2.89 inches taller than the average female. A male who is 67 inches tall will have a residual of 67 minus the mean height for males, 69.23, which gives us a residual of negative 2.23 inches, indicating that a 67-inch tall male is 2.23 inches shorter than the mean height among males. We talked about several measures of variation in Chapter 3. Coverage intervals, percentiles, range, interquartile range, standard deviation, and variance. We're going to be working a lot with variance because variance has a very useful property, and that is that it partitions the total variation in a variable into the variation that's explained by the model and the remaining variation, which we call the residual variation. So what this means is that the variance of the height variable is equal to the variance of the group means plus the variance of the residuals that are calculated. And we're going to do an activity to see that this is true. Groupwise models can have several purposes. One purpose might be to determine whether the groups are actually different or not. So is there a difference in the groups? Could use a groupwise model for that. Another thing we might use them for is to make predictions. If I want to predict a person's height, I can make a better prediction if I take into account their sex than I can if I don't. So it can be helpful in making predictions. And then the other reason that we might be using groupwise models is to try to help us understand phenomenon in the natural world. Sometimes it might be helpful to know how large the difference is between two groups, in what direction the difference is, and to try to use that to figure out what it's telling us about the way the world works. When we're trying to evaluate differences between groups, one question we often need to ask ourselves is how big the difference is and if it's large enough to have any practical importance. The second question we often have to consider is how sure we can be that there is any real difference at all. Remember that usually we are using data from a sample to understand a phenomenon in some larger population. And the group difference that we observe in the sample is only an estimate of the group difference in the population. So we have to have an idea of how good our estimate is or how precise it is. When we are communicating the precision of an estimate, we usually use something called a confidence interval. And Chapter 5 is going to talk all about confidence intervals. So we're just going to give a brief preview here. But a confidence interval gives a range of values that we're confident includes the population value that we're trying to estimate. The form that confidence intervals take is they take a single number estimate, called the point estimate, and then they add and subtract a margin of error. And the margin of error has some sort of confidence level associated with it. Usually we use 95%. So for instance, if we made a 95% confidence interval for the mean, we would be 95% confident that the interval that we make captures the true mean that we're trying to estimate in the population. It's also sometimes useful to look at groupwise proportions models. For instance, we might be wondering, at a company that has been laying off employees, are workers in all job categories equally likely to be terminated? And if not, which categories are more likely to be terminated? And we could look and break the workers up into job categories: administrative, manager, principal, which is someone who owns the place, senior or staff, and then look at the proportion, or here it's actually represented in percentages, of people that are retained and terminated in each group. Now we can see that among jobs that are categorized as senior, 90% of people were retained, whereas staff, 88% were retained. That is a difference, but is it a big enough difference to be meaningful? And are we sure that it's a real difference, that senior staff are less likely to be laid off and more likely to be retained? Or is it a difference that's so small that it might be due to random chance? These are all things that we're going to consider later in the course. Another example of looking at group-wise proportion models, same company, but now we're wondering, are workers of all ages equally likely to be terminated or not? And if not, which categories are more likely to be terminated? And here age is broken up into age groups, and we can see that if we look at the people in their mid-60s, it appears that that group is more likely to be terminated. Again, we need a measure of precision to be confident of that answer, though. So in class, we are going to work through an example to see that variance does partition the variability into that which is explained by the model and the residual variation that's not explained by the model. We will also consider a cautionary tale that shows us that group-wise models can sometimes give misleading results. And finally, we will learn some new computational methods in R that we can use to create group-wise summaries and group-wise mean models. If you haven't already done so, please read Chapter 4 in the textbook, and I'll look forward to seeing you in class. Have a good day.